If you have your notes to feature self out, go to this part right here. Or if you don't, write down this right now, because these are the words we're going to kind of be looking for. Okay. There's one thing I'm going to add here. For some reason it won't let me type. I'll type right there. Good. Shoot. I just realized I have a really good handout for this, but I don't know where it is. Give me 30 seconds here. As we go through, once we're done, I will find that handout. So we've dealt with how to solve this week through factoring, how to complete the square, and we did quadratic equation yesterday. So we've done those 3 things over the last 2 days. Now we're going to convert that into word problems. But the key here is like knowing what the words mean. Okay. Words such as max or minimum value, highest or lowest, okay, most or least or optimal value are all words that link with the vertex. Okay. So if I was looking for the highest part of my jump, if I was to jump off something, that would be dealing with the vertex. If I'm diving into the water, if I'm looking at something that's going into the water, it might be how low does it get? And that's a vertex, because if I'll draw some diagrams here real quick, kind of put it in context. So if I were talking about a person jumping, I don't have brown up here, do I? I don't brown anywhere. All right, let's say that's a cliff, right? If I was talking about a person jumping in, and I want to know the highest point of their jump, that would be the vertex right there. Okay? If I was looking at profit, this was a chart about profit of a company. I was asking what price should I sell something at? That would be referring to the vertex, right? If this was like, if I was selling sunglasses, if I sell them for $5, I'll sell this many. Or if I sell them for $20, I'll sell this many. What's the best price to get the most profit? Okay? So those are all words that deal with vertex, optimal value, what's the least, okay? When we're dealing with x-intercepts, I'll draw a graph like this. If I talk about hitting the ground, right? If I go back to my cliff here, let's talk about water, right? If I had something where here, I jump off here and ask, okay, at what time do I hit the water? In that case, I would be dealing with an intercept, right? With the water being considered like 0 along the x-axis, right? This would be like the x-axis here, and the cliff being the y-axis. So that would be considered a vertex, okay? Break-even point of a company. So if this was a company here that was making money, okay? Right, if we go back to our sunglass people, here's our sunglass sales again, right? I would be looking at these 2 points as my break-even point, as in when do I make money in this graph, okay? So that's looking for x-intercepts. And then lastly here, I said starting point. If I was to jump off here and say how high was I when I started, this would be considered the y-intercept. Does this make sense to everyone, kind of how we're linking the words to a real life situation? Yes, no, maybe so. Okay. And there's actually real life parabolas. I know you guys don't believe me that math happens in real life, but for example, who can tell me what this is? I'll pull up a picture here for you. I can't include the title. So who knows what this is? Oh, that's a big one. Any guesses to what this is here? No one knows what this is. Oh, uncultured people. No guesses? That's the St. Louis Arch. It's a big arch in they built in St. Louis. Actually, you can go up to the top point there. They have like this elevator that goes up. You can actually go up there. Yes, it is a parabola as well, right? It is a parabola. So there's like a problem. There's like a question. Okay, like if this is the equation of the parabola, how high is it, or things along those lines. So that's a parabola in real. Okay, so where's my other picture here? I'm trying to get a side picture of this item. Here, I think. There we go. Here's a good side picture. Who can make a guess what that is? And don't say bridge. It's a very famous bridge. We all see it's a bridge.
The Golden Gate Bridge.
Pardon?
The Golden Gate Bridge?
This is the Golden Gate Bridge. Golden Gate Bridge is in San Francisco. Tons of movies, scenes a bit on this.
My favorite song is I Left My Heart in San Francisco by Tony Bennett. I love that song.
Oh, yeah?
Yeah,
Nice.
great song. One of the best
Yeah,
songs out there.
It is pretty good. We'll play that when I start your, remind me, we'll put that on when we start homework. You can see this is a suspension bridge. So these wires, all vertical here. Here's a better picture of what it means here. These wires support the bridge, and this here is a parabola, right? Along those lines, okay? So there are real world situations where parabolas exist. They're really strong. Flight of a ball is always a parabola. Like if you throw a ball up in the air, not vertically, as long as it's not vertically straight up and down. But if you kick a ball, if you throw a football, kick a football, anything like that, it's going to make a parabola. Okay, so flight of a ball. If I were to like jump off a cliff, it's a parabola, and things along those lines. Okay. So before we get started, let's do attendance. Then that might give me a chance to find.
You gotta remember to record.
The item. Oh, I already did. Mia was on it.
We're good.
Already. Oops, that's not what I wanted.
Are we voting today, Mr. O?
You should have voted yesterday. It's in your email.
Yeah, I voted for Amelia Glab.
All right. You don't need to release who you vote for. It's a private choice. Teachers get a vote for student council.
I voted for Amelia Glab and Sophia Kozarin.
Ye same Dominic.
Hey, Mr.
where-
Roll,
Only time our political views have ever aligned, Dominic. It's really weird, dude.
Carly,
it's funny.
you had a question?
I think we already did the attendance meeting.
What do you mean? No, this one's new.
Oh, this one's new? Oh. Okay, because it looks similar to the last one.
It's about bacon,
I have to
sausage, and ham,
volunteer
right?
today. We've been here for 20 minutes.
Oh, okay. My bad.
Alright. 1 second, I gotta find this handout. I have a wonderful handout. I just need to find it. I think I handed it out in class. 2021 math cheat sheets. No. Okay. I will find it once we're done here. And I'll help you out in how to change everything over. Okay, that's fine. All right, so what was our results? 59% bacon, 27% sausage, 13% fruit bowl. Nice. I think Farley voted twice somehow.
Can I say something?
Go ahead.
Okay, so yesterday I went to Tim Hortons, right? My dad. No, 2 days ago. And I ordered a bacon sausage biscuit. They only put the sausage. It's this one Tim Hortons, man, the one that Ben works at. They keep screwing me over, man. They owe me so much free food. Horrible, man. Seriously.
I'll actually get you something this time.
Seriously, bless up, dude. Sarah's got to stop like every time I want to go coming to the thing.
You lost another 2 supervisors, Gabe.
Who'd you lose?
Ash and Margaret.
Oh. Down bad. Maybe I should step up and come back, be a supervisor.
Okay, here we go. Let's get started here. So, we're not learning anything new today. We are just applying what we've already done. Okay, does that make sense? So we're applying how to solve, how we solve their quadratics, like how we factored, then we define zeros, how to find vertex. So you're just going to use the different strategy we already know. And I'm going to grab that handout. It's a great handout. So we already talked about this. Quadratic problems need context. The context can hide in it, right? You have to look for keywords of what you need to find. Okay. And there's no way you can solve it however you wish. If you love the quadratic formula and you just want to never factor again and use quadratic formula to find your zeros every time, that's fine. Okay. If you want to find your vertex by factoring or by using quadratic, finding the axis of symmetry, then finding the vertex using that method we did, was that Monday morning? You can. If you'd much rather do complete the square to find the vertex, you can. Okay, so there's no wrong answer to get to the right answer. Okay, it's not like if someone does completing the square is better than someone who factored then found the axis symmetry and so on. Okay, so for these first ones, for the morning ones, you're more looking at factoring to find zeros. Okay. So if we look here, a rock is thrown down from a cliff that's under 180 meters high. Now, you may laugh at me. I like to draw diagrams all the time with these questions. I always draw like a little sketch. Okay. So I'm going to draw my cliff right here. I know this is 180 meters high. The function of height versus time is -5t squared minus 25 plus 180. Gives the approximate height of the rock above the ground where h is height and t is time. When does the rock hit the water? That's the question. So I throw a rock off here. Where is black? So I throw a rock off here, and it's going to go like this. Okay. So this is height here. We're looking at height. And along the bottom, we're looking for the letter that's in here is time. And we're looking for this spot right here. So the first thing we have to realize is, what are we looking for? Are we looking for the vertex? Are we looking for x-intercept? Or are we looking for the y-intercept? Which one of these are we looking for? X-intercept. Good job, James. Good. We're looking for the x-intercept. So we're looking for when it crosses there. Now, we have two strategies to get there. Okay. Strategy one is, I'll put it over here. Strategy one is we can factor. Strategy two is we use the quadratic equation that we learned yesterday. Your choice of which one to do, okay? If you want to use a quadratic equation, go ahead. That's fine. Whatever gets you to the end works. Me personally right now, this looks like something. I'm going to first try to, I'm going to first try to factor it. And if I can't factor it, then I'm going to go to my second strategy. Does that make sense to everyone? All right. So my formula start is -5 t squared minus 25 plus 180. Does anyone have an idea what we could do first to make this a little bit easier to factor? What could we do to this equation to make it easy to factor? I'll put a hint down here. Oh, common factor. Perfect, Olivia. So let's try to common factor at the -5 first. Because we all know that just factoring something with just the t there, we've always used x's. So if we common factor out the -5, so we're going to divide all this by -5. So that's going to leave me t squared plus 5 minus 180 divided by 5 is 36. Okay. I'm going to leave this here real quick for you guys to factor. Oh, I forgot my t here. Don't write it in chat right now. I want to see who can figure it out. I want to give you a chance to figure it out. And just remember the two things that are going to go in the blue spots, multiply to make t squared. And two things that go in the red spots multiply to make negative 36. Okay? Put a D in chat if you think you have this factored already. Okay. Who should we wait for to be done factoring? Oh, I was going to say Kovacs, and you hopped right on there. Gabe can do this. We worked on this yesterday. All right, so type in chat if you have it. Type in my my items here. What's my factors? This is going to be t and t, because the only thing that multiply to make t squared is t and t. But what's my other numbers going to be here? All right. Let's focus on the task at hand, Riley. Someone write in their factors there and tell me what numbers are going to go in here and
Speaking
here.
of sports, what do you think about Jason Tatum dropping a 50 burger with cheese on the Washington Wizards last night?
I think we're doing math right now. That's what I think. It's not 6 and 6. Because remember, they have to add up to be this 5. Right? So if we put 6 and 6 in here, now one's got to be a plus, one's has to be a minus. Those are going to equal 6t and negative 6t, which equals 0 here. So it's not 6 and 6. What numbers do we have? 9 and negative 4. Okay. So 9 and 4, because 9 times 4 equals negative 36. But 9 plus negative 4 equals 5. So those are our factors. Now we're looking for our x-intercepts. So how do we find our x-intercepts when we have the factored part here? Okay. I'm going to rewrite this. Let's focus on the task at hand, boys and girls. I don't know if there's a girl involved in that conversation as well.
Dude, the NHL needs to split up the North Division. I'm tired of that. Like,
Gabe, no more. So what do we do here to get our zeros? We pull these out and make them equal to 0, right? 9 plus 9 equals 0. So t equals negative 9. And t minus 4 equals 0. So t equals 4. So which answer here is my right one? Does the rock hit the ground at 4 seconds or negative 9 seconds? Which one? At 4 seconds. Why is there only one answer to this question? Why is this one here not an answer? Why can't that be an answer? Why can't negative 9 be an answer? There's a hint of why. Why can't negative 9 be an answer? Right. You can't go backwards in time. Right? Right? You can't, like, the rock can't land 9 seconds before you threw it. So you can't have a negative time aspect. Good. How do we feel about that question? Does anyone need to review any aspect of it? So to review, we read the question. We figured out we needed to find the x-intercepts. That's what we needed to find. Then we looked at it and said, okay, if we need to find the x-intercepts, these are the two things we could do. And then we advance from there. Here's a little twist on this question. Okay. So our original equation is, let's write down our original equation. H at t equals negative 5t squared minus 25 t, make that a big T, plus 180. Okay. This time it says, when will the rock reach a ledge that is 110 meters above the water? So let's redraw my thing here. I'll put a ledge here. You might not notice, but I had no chance to go to art school when I was done in high school. Like, no chance at all. So I apologize for all my drawings. Now we know this is at 180. Okay. This here is at 110. Now, I'm going to go back up here and change something with this one. I'm just going to add something in here. We want that to equal 0 because we consider the water at 0 height. Does everyone agree with me here? Okay, so all these here as we work through would equal 0, which is the x-intercept. Okay. Now, with that in mind, if we're asking when will the rock reach a ledge 110 meters above the water, where in this equation would I put the 110? Anyone have a guess of where I want to put the 110?
For H?
For HT, very good. So I would replace this here with 110 equals negative 5t squared minus 25t plus 180. The way I visualize this is we kind of take this line here, like the very first time we tried to find this blue line, and we're just moving that line up. So now we're kind of making our 0, for lack of a better term, right here. Okay? So we moved it up to there. Does that make sense to everyone? That's how I picture it. So now your x-intercept, for lack of a better term, is occurring right here. So instead of finding the 0, we will find the 0, but we're moving that line up. That's how I visualize it. Now, in order to solve this, we're going to do the exact same thing, but the very first thing we need to do is just need to move this over here. So this would become 0 minus 5t squared minus 25t plus 180 minus 110, because it was a plus on its side, so it's going to come over and become a minus on this side. And then we simplify from there. That's plus 70. Any questions? I'll slow down right here. Any questions on what we just did? Or does that kind of make sense once you look at it? So once again, we need to find our zeros, or our x-intercepts. What's our two strategies right now to find our x-intercepts? We could, number one, we could factor. For number two, we can use the quadratic formula. Okay? Let's once again factor. What's the first step I need to do here? I have 0 equals negative 5t squared minus 25t plus 70. What's the first thing I need to do? I want to say Haley can't answer it this time. I think she answered it before. No, it was Olivia who answered it before. What do I need to do here? I have negative 5t squared minus 25t plus 70. Is it easier to factor with just a t squared there or with a number in front of it? Good. Common factor out that number in front. So we're going to common factor this out. We'll divide everything by negative 5. And generally, if you can't common factor it out, if it's a big number, then just use quadratic formula. Plus 5t minus, that is, I want to say 15. No. What's wrong with my head? I was wrong. I was dividing by 4. Okay, and then factor away. Now, if you get the factors, I want you to work all the way to the bottom and find your time of what it gets there. So put an F in chat when you're done factoring, but then don't wait for me. Continue through and see if you can find what time it would hit that. I need to do my attendance. Would we get the same answer if we just isolate and solve for t? Yeah, that's what we're doing right now, Olivia, anyways, is we're isolating and solving for t. But because there's like a t squared, this is how you do it, right? Since there's a t squared and a t, I just can't move them to one side of the equation and then work it out. This is how you solve, you factor in order to solve for t. Okay? So essentially you're right? But this is just a strategy of how to do it. So Dominic said that 7 and negative 2 go in here. Plus 7, x minus 2. So we have our factors, then we split them to find our zeros. So that means our answer has to be 2, because we can't go back in time. So after 2 seconds, it would hit the ledge. How do we feel about that? Good? So we're just working with how, we're essentially like working with how we graph it and figuring out what we need. Okay? So let's go down to the next question. So this one here says Snowy Snowboard Company manufactures snowboards. Hopefully manufactures snowboards with that name. The company uses the function, this, to model the profits in thousands of dollars. And X is the number of snowboards sold in thousands. How many snowboards must be sold to break even? Okay, so first thing we're looking for here, are we looking for, oops, y-intercept, x-intercept, or our vertex? What are we looking for here? I need tense real quick here. Abigail Andreas. Have I seen Tessa yet today? Let's see more. Tessa's here. And I've seen Brandon. I've seen Riley, I've seen Andreas, seen Abby, I've seen Carly, I've seen Laura. Yep. Ethan. Yep. Gabe, I've seen Brianna. Yep. T, I've seen Kane, James. Mia, I've seen. Logan, I've seen. Haley, I've seen. Mueller, I've seen. Jackson. Yeah. Sam Vito, I've talked to. Michael. I have not. Yosan. No Yosan yet. And Dominic. Okay. All right. So we're looking for, if we're looking at break-even points, if you go back to our notes to self, if you look here, break-even points is x-intercepts. Because if we think about it, if we have a chart of, this is my chart, this would be my profits, this would be my sales. Okay, it's going to look like this. Oops. Right? At some point, we're not going to sell enough to make money. But after so many sales, we're going to start to make money. Then, after so many sales, we're actually going to start losing money. That doesn't really make sense to some people, right? So we're looking for these 2 points right here. The way you could start losing money by selling too much, like if you think about like donuts, since everyone in my class is employed at Tim Hortons, right? If you have to hire so many people to serve, but you can't sell as many donuts as you possibly can, like you just can't sell donuts going up like this because there's only so much room in your store, or right? You actually start losing money by selling it. Okay, by selling too much of one thing, actually you won't make as much money. You won't make money on that. So it's break-even points where like the low part and the high part. So we're looking for our x-intercepts again. Okay. Tim's is never really dead. You have crazy people going there in the morning and waiting 10 minutes in their car to get a coffee. It's ridiculous. I never wait in line. All right, so.
No one's been going to Tim's anymore because they found out that I left.
So, here's the question I'm looking for now. Okay, we know we want to find our x-intercepts, so we have 2 choices. We can factor, or we can use the quadratic. I always favorite the factor first. Okay, so let's take a look at this equation. Profit of x Now we want the profit to equal 0 in this case. So it's our break-even point. So when the profit's 0 equals 324x minus 54x. Okay. X squared, sorry. Can we we don't have a third number here, okay? So the thing we can try first, so what we've done the last 2 times, is common factor, right? So what is the same? What's common between these 2 terms right now? What's common between these 2 terms right here? Uh, 54 is good, so I can take 54 out of it. And I'll move my line down here a little bit. So I can divide each by 54. And that's going to leave me with 6 minus 1. What else is also common between those 2 things? Oh, Dominic has it too. X is also common. So I could divide each by x. I'm going to be left with 1x here. Does that make sense to everyone? So we common factor that out. Now we can't go further than that. Like we can't factor that anymore. So now we split it. So in this case, we get 54, x equals 0. So I divide each side by 54. Cancel. That's going to equal 0. So x equals 0. And 6 minus x equals 0. Now I need a positive x. I'm actually going to take that over there. 6 equals x. I'm going to wait for everyone to catch up. And Riley and everybody, let's wait till after the lesson before we start thinking about hockey and stuff. How did we understand this? How does this feel? Good? Bad? Made sense? So in this case, if I were to draw my graph, I know there's x-intercept at 0 and an x-intercept at 6. Boys, we're shutting down the hockey talk, okay? You guys can talk all you want on break, but right now, you guys need to focus on this. So in this case, they could either sell 0 boards and break even, or 6 boards and break even. Any more than 0 or 6, well, you can't go any less than 0, but any more than 6, they start to lose money. And this could be a case where the guy just works in his shop at home and just works in his shop, and that's where he produces it. So if he were to have to produce like 10 boards, he'd have to like rent a space and start doing that type of cost. Okay, put a G in chat if you're good with that question. Let me go on to the last example. Okay, here's one where we're going to find, I won't show you that. Pretend you just didn't see that. Okay. So a computer company models the profits of the latest video game as the function px negative 2x plus 32x minus 110. For x is the number of games in thousands. Oh, sorry, that last question was in thousands, wasn't it? That doesn't make any sense. We sell 6 boards. It makes thousands of dollars. There we go. Okay. Where X is the number of games in thousands that the company produces, and P of X is the profit. What is the maximum profit the company can earn? Okay. So are we looking for y-intercept, x-intercept, or the vertex when we're asking about maximum profit? The vertex. Okay, good. So we're looking for vertex. Now, what's our strategy? Can someone suggest a strategy to find our vertex? We have two ways to get there, to get to our vertex. We could factor, right? So if we factor, after we factor, we need a line of symmetry. Then we need to find our vertex, okay? So the factoring one has three steps in there. What's the other way we could do this? One second. I'm not looking at chat right now, so if you wrote something in, I haven't responded, I apologize. We could complete the square, too. Now, completing the square has less steps, I think. There's less spots to go wrong with completing the square. Now, with factoring, you could also use the quadratic formula to find the zeros first. That's why I prefer to, I'm going to complete the square. Okay. This is where I say having your notes to self and all that handy is good, because you can look back and say, okay, what's my steps to complete the square? So let's write it on my formula here first. Negative 2x squared plus 32x minus 110. Should I bring up my steps to completing the square beside here? Yes, no? Okay. I will need to find that real quick. All right. I think I sent this, did I? I think I sent this out to everyone. I think I'll also put it in here. So you're completing the square notes is in here. Let's squeeze this off some. I've completed the square with no leading a value, but we have a leading a value here. We have a number in front of our x squared. So I'm going to go here. Why is that like that? All right. So it says the very first thing we do, factor out the a value from the first two terms. Okay. So as we go back here, let's do step one. So I'm going to factor out the a value from the first two terms only. So these are x squared minus 16x minus 110. Okay. Step two, divide the b value by 2 and then square it. Negative 16 divided by 2 equals negative 8. I'm going to put a little star beside that for later. Negative 8 squared equals 64. Okay. I'm going to pause here for a second just to make sure everyone's caught up. Now you can see how our lessons kind of grow on each other. This is our last quadratic lesson before we're going to have a little a test on Friday about it, and I'll talk about how that's going to work later today. So tell me, put a C in chat if you're caught up with me. Okay, Farley, Riley, you're good? Good. Good. Now, if you know how to complete the square, go ahead and finish this, and then double check your answer against mine. Right? Now, step 3, inside the bracket, add and subtract the number from step 2. Right? Step 3, so I have -2, bracket x squared minus 16, x. Then I'm going to add and subtract that number, so that's 64. So I'm going to add 64 and minus 64 from it. Good. Step 4, remove the negative. It's going to get rid of the negative, but it has to multiply by the leading number there. So -2 times -64. Plus 128. I do believe. Yes. Oops, I wrote that in the wrong color. And I'm writing over it. Plus 128. Then step 5, combine your terms outside the bracket. Uh, 18. Wait for, put a, what letter should we go in chat right now? Put a number 6 in chat if you're caught up with me. Good. Then we're going to factor our middle part here. Okay. So remember, it's a perfect square. So it's going to be the same number in both sections. Can someone tell me where I can find that number? Or what is that number that we're going to put in here? What number am I going to put right here? Can someone tell me that? -8? Good. Remember, it's that number I start up here. When you first divide it by 2, that's the number you're going to put in here. Okay? So that's why I kind of take a moment, make a note of it, because you're going to use it later. Then my is x minus 8 squared plus 18. Then I can find my vertex from it. My vertex is, oops, 8, 18. Okay, so my vertex is 8, 18. So let's bring that back up here. My vertex is 8, 18. And that is, in terms up here, that's X and P, okay? Actually, I'm going to switch up my colors here. That's X here, and this is, give me green, P for profit here. Now, if we take a look here, X is the number of games in thousands sold, okay? So can someone tell me how many games were sold? How many total games were sold by the company? $8,000 games. Good. Okay. And P is profits in millions. So how much profit in millions did they make? Profit in millions, right? So P is our profit in millions. So how many profit in millions did they make? Knowing that's our P number, right? And this was our 18 million. Good. So there's the answer to our question. What's the maximum profit that they can earn? $18 million profit is their maximum they could earn if they sell 8,000 games. So therefore, like when we look for max profit, use completing the square. That's probably the most efficient way to find it, instead of going through factored, line of symmetry, vertex. Okay. So let's take a look at your homework, your practice for today. Is that off? You have 5 questions, and they're very similar to the ones we did. Let's skip question 1. Do question 2, right? Question 3, question 4, question 5. Okay, so skip question 1. Now, if I look through this here, I see some names that aren't bolded that tell me they haven't handed anything in since yesterday. Because I should be able to go through, I gave you guys lots of time to do your homework. Pick a random student. Let's pick T. She has a bold beside her Tuesday hand-in because she handed in her homework because I gave her lots of time yesterday to complete it. Okay? So when you guys have the afternoon to work on your stuff, to catch up and so on and so forth, I should see everybody's name bolded here when I go through to do homework. Does that make sense? So I will give you to 11 a.m. to complete this work. Riley, are you there? Okay, just making sure. All right. And for the people who are asking me about my hockey picks, I have friends who are Leaf fans, so I can't have them win the cup because I'll never hear the end of it. So I don't care what happens in the NHL playoffs, my team's not in it as long as the Leafs don't win. I'd like to see Edmonton play long into the playoffs because McDavid's the most exciting player, and go from there.
Wait, who's your team?
I grew up near Ottawa, so Ottawa's my natural team. So
You don't really like hockey, though, do you?
not as much as I used to. I used to watch tons of hockey, but now my life's too busy.
Benfica.
I can still tell you everything about hockey, pretty much. But that's just because I'm a general sports fan. If that makes sense. Yosan, do you want to go over some of the work so far today? I'm going to stop recording for the first time.